welcome.
Hi, Savon. Thank you for hosting.
So Ara is the head of data service at Dreamworks, where he directs the development of the database as a platform that's hosted on Kubernetes, obviously. For those who don't know Dreamworks, it's, as Bart said, it's an American animation studio that produces animated films and television programs. And Ara actually started to develop this container database as a service platform in Dreamworks in 2017. And then he went to work as an SRE at NASA. But then his health brought it back to Dreamworks, if I may say, where he took on the role of a cloud architect to develop the company presence in other data centers and in the cloud. Welcome, Ara. So let's get the conversation started. You have, as you told me, since 2017, been a Kubernetes user. And so what stateful workload are you running on Kubernetes? And if you have any interesting numbers, like number of cluster, amount of data, QPS, this sort of thing, please share them.
Okay. Well, first, Savon, thanks for the introduction, and thanks for hosting. So almost all of the stateful applications that the data services team at Dreamworks deploys today, as you mentioned, are deployed to Kubernetes. This includes database types like Cassandra, Couchbase, Consul, Kafka, Elasticsearch, Redis, RabbitMQ, MongoDB, and Zookeeper. This list should include Postgres soon as well. As far as interesting statistics go, we're running around 370 databases at present, over 1,200 pods.
Thank you, Ara. So yeah, it's quite interesting. Like we, as our data and Kubernetes director, Melissa said this morning, data on Kubernetes is a thing, and organizations are running all sorts of stateful workload on Kubernetes, from storage, databases, archive, backup, streaming, and so on. We've also seen users that are running nearly the entire stack on Kubernetes, including their stateful workloads. Do you have anything around machine learning? We've seen that a number of organizations who are really advanced with Kubernetes see Kubernetes as kind of like the next thing when it comes to hosting machine learning workloads.
So as far as machine learning workloads go, that hasn't been necessarily in the purview of my group. We have had other teams across the studio show interest in using Kubernetes for those kind of workflows, but that kind of work hasn't been taken on by my team.
Right. So as I mentioned, Ara's kind of specialty is database, but it's quite interesting that, as you said, the almost entire stack of Dreamworks is on Kubernetes. I think that really reflects what we've seen in the survey. So let's get into it. Like, why did you decide to move stateful workload to Kubernetes? What were the driving reason that push you to do that?
Yeah, so the introduction of Kubernetes was really like the natural evolution for the database as a service platform that we had been working on for quite a while. So when the initial work for this database as a service platform started, the problem statement was fairly simple. How do we run a lot of database clusters on bare metal on-prem infrastructure? And we kind of looked to Linux containerization, Docker, as the first piece of the puzzle. With the first Docker-based iteration of the platform, we knew that there were several weaknesses that we wanted to address. There were specific parts of the provisioning process that we were still either doing, totally manually or using bespoke automation. And this included things like selecting specific hardware based on available resource capacity, determining available IP addresses and configuring container networking, carving out local volumes for persistent storage, and creating and updating DNS records. So, with these kind of weaknesses around, even basic things like reacting to a node outage or something like that was difficult. With Kubernetes, there was an obvious way to kind of like check off all of these boxes. Scheduling workloads was handed off to the kube scheduler. IP address management and container networking configuration became a function of the CNI. Storage provisioning, we offloaded that to our storage driver. And the management of DNS records based on the current state of things that were running in Kubernetes was handled in an automated way using a controller that we've been using called external DNS. So it really solved all of the sort of gaps that we had in our bare Docker-based implementation.
Very interesting. Yeah, like doing containers in production in 2017 was definitely being a pioneer, right? Like people are like, oh, cool, container, it's a very cool toy.
Yeah.
But then when you wanted to do anything production related, we are like, well, especially for stateful workload. I think even stateless workload at the time, it was kind of bold to use containers. And I can see, why like Kubernetes basically like came as like the messiah. Hey, like we can solve all of these issues that we are having with containers. So maybe let's take a step back then. So why did you decide to use containers for stateful workload? So not Kubernetes, but container in the first place, because in your answer, I understand that you started with Docker containers. What were the reasons that you had in mind for that?
Yeah, I mean, the reasons are fairly simple, right? If we want to co-locate, let's say like 10, 15 different Kafka clusters on the same set of, on the same set of physical machines, machines that maybe have 128 physical cores and, a terabyte of RAM. We had to use something, whether it be VMs or containers, to kind of isolate environments. Containerization in general was kind of gaining traction, and it seemed like a good way to sort of package, database applications. We can, release or build new images to capture, or to match new version releases and things like that. So yeah, it was a mechanism that we used to isolate and co-locate, many database clusters.
And so you mentioned that the reason why you joined Dreamworks a second time was to expand the company footprint in other data center, and I believe the cloud. So was this transition to hybrid driven in big part by Kubernetes?
No, not really. Actually, it's kind of, although there is something to say about it, because of the way we had approached, deploying databases on-prem, moving into an environment like Azure, where you can just spin up a managed Kubernetes cluster, and you have the sort of same interface to interact with to deploy the databases that you've been deploying on-prem, for a year or so. The transition into a cloud environment was, very, very seamless, right? It was just another hosted Kubernetes, to point our CD pipelines to. But yeah, it wasn't driven by that, but it very much facilitated expanding into different environments, which I think is, demonstrates the power of a common API across, both, on-prem and cloud environments.
According to this, the report that we just released, you can download it on the DOK website. We surveyed about 500 organizations, show that Companies are hybrid, and we had like actually almost nearly identical distribution between on-prem, cloud, and private cloud and public cloud. And as you say, like Kubernetes is a way to be hybrid, but also to avoid this, famous vendor locking. And that's true for stateless and for stateful workload, obviously. So now that you've been doing this for years, can you share a little bit about the benefits of really using Kubernetes as kind of the standard way to pretty much deploy anything at Dreamworks? We found out that productivity was something that organizations that were running Kubernetes at your scale, and here I'm speaking about 75% of their production workload or more on Kubernetes, reported being as much as 2 times more productive thanks to that. So is productivity something that came thanks to that? Do you have other benefits that you've seen since then?
Yeah, for sure. So all the manual work and custom automation, that I was referring to previously, all of that simply evaporated with the adoption of Kubernetes. And our goal of being able to scale to support a very large number of database clusters without needing an explosion in the headcount required to manage those same databases was really made possible by that move. And kind of another overlooked benefit has been kind of the consolidation of technologies used within Dreamworks. So Kubernetes was already being used in the larger platform services organization at Dreamworks prior to the data services team adopting it. Our sister team, which manages stateless microservices, had adopted it, years prior. So by standardizing on a common platform, the two teams were really able to share ideas and build upon a common set of core technologies. It's become very common for us to collaborate on building out, some underlying feature with the platform itself. Advances that one team makes really it benefits the other as well. So yeah. Yeah.
Yes, standardization is definitely a huge reason why organizations are moving to Kubernetes. And actually, the more you migrate to it, the more you can kind of compound and capitalize on that. It's quite interesting that you say that the fact that you use Kubernetes enabled more collaboration between teams. And especially, I'd like to hear more about DBA. Do you think that the fact that we bring more standard to the data management will empower the management to become more streamlined and straightforward? Like today, if we think about the way we manage storage and compute, it's very easy. For database, it's still quite complicated, not only database, but stateful workloads. So do you think that thanks to that, Kubernetes is going to become more like a commodity, like something that we manage as easily, and therefore teams will be able to focus on more not interesting problem, but perhaps more other type of problems that are going to be closely linked to the business?
Yeah, for sure. I think we're kind of at well, maybe not anymore exactly, but when we were first building out this platform, it really felt like we were kind of at the cutting edge of doing what Kubernetes was capable of accommodating as far as workloads go. We we sort of we sort of saw a lot of the conventional knowledge that's been alluded to in other talks about avoiding running stateful workloads in Kubernetes. But for us, the benefits, as you said, consolidating on a set of core technologies that multiple teams can use allows us to kind of focus on, not necessarily managing some of the more menial work that had gone into the way that we were deploying databases previously. A lot of the sort of manual decision making that DBAs had to conduct to spin up a new database cluster. All of that has been taken on by automated controllers, and it's allowed them to kind of think about problems at a higher level problems. So yeah, it definitely has allowed us to not have to occupy the mental bandwidth to kind of handle some of the more menial operational tasks.
Wow, all of this sounds amazing. Like, I think the audience is like, okay, like, let me port everything to Kubernetes, but wait a second. It cannot be that easy. I'm sure you face a lot of challenges, outages. Like, can you share a little bit about this? Because, I mean, moving to Kubernetes, obviously, like, it's the future of infrastructure, but at what cost? Like, what challenges did you face? How did you solve them? Any juicy outage that you can share about? We want to hear from this.
Yeah, actually, when I think about the outages that kind of the nightmarish outages, they actually predate Kubernetes. Say some of the challenges that we faced. I'll provide a bit of context first. So we actually decided to build our own operator or set of operators, and initially when we were kind of thinking through how we leverage Kubernetes for database deployments, we had a lot of different vendors that we had relationships with that were providing or intending to provide their own operators for the different databases and stateful applications that we were using. But we wanted a way to be able to ensure operational consistency across the different database types that we support. So so we ultimately decided to build our own operator. The way we kind of sought to maintain that consistency across types, application types, we took on an approach that was a little bit different from some of the operators that we had been seeing. Our goal was to essentially decouple implementation-specific logic from the operator itself. So rather than tying the operator to a specific set of database types, we try to encapsulate database type-specific implementation details into the underlying container images using a standard that we kind of developed internally. So to give an example, while taking a backup of a Couchbase cluster might look different than taking a backup of a Cassandra cluster, we wanted the operator to be able to, not necessarily know about that. We wanted to be able to interact with the underlying containers in some general way to take, a backup, and that way it would be able to do a common set of operations across different database types in kind of a generalized way. So one of the challenges of that was building a lot of the work to get this platform off the ground was building images that were compliant and actually coming up with the standards themselves that governed how those images were to behave. So, there was a lot of upfront cost associated with, as you know, different database types. There's going to be a lot of differences across them, right? The way they discover peers, the way they handle nodes crashing, et cetera. There was a lot of upfront investment to make sure we had images that could be interacted with by a generalized operator that that would allow us to run databases in this way.
Interesting. So it's the first time I hear about this paradigm of building kind of like one can-do-it-all operator, but rather adapting the images so that it works. You said that you took this decision back when vendors were not developing their operators, and basically you had no choice. Do you still believe that this technical tech was... was the best? Are
We
you
had
still doing
a
it? Go for
no
it.
at that point we did like a lot of a lot of our vendors were um, uh, at least planning on releasing their own operators in the near future. So it wasn't an approach that we decided on because of the lack of options. We knew that those were in the pipeline, but we decided on this approach again to make sure that we didn't have to train our DBAs to understand how to use all these different operators, right? We wanted a common spec to define a database in a generalized way. And the thing that this has really helped us with, right, is if we need to onboard a new database type, let's say one of the development teams comes to us and says, we need database X supported by you guys. The work that entails then is simply a matter of creating a new compliant image. It wouldn't have to necessarily involve changes to the underlying operator, or significant changes, I should say.
So for those on the audience that don't know about operators, they are basically extension of Kubernetes that allow user to do kind of the day two operation specific to each application. So if we take the example of the database, it would be, hey, I need to apply a patch, or I need to upgrade, and you need to, shut down the node of the database in a specific order, which might be different, let's say from Postgre to Couchbase. And so Kubernetes cannot manage this natively, and so you have to embed this piece of logic in operators. Operators are actually the main barrier of adoption for data on Kubernetes. We found out through the survey that 40% of respondents who are not running data on Kubernetes and believe it's not ready was for the lack of quality operators. And I think what you are sharing with us is reflecting what we found out, is that the lack of standards is making the management of this operator extremely complicated, because everybody is, and by everybody I mean vendors or end users, are developing it with kind of their own take. And so it's very hard then to streamline, and every time you use a new operator, it sounds like you need to learn something new, which is why you decided to build a one-fit-all operator and then make your images compatible with that. Is your operator something that's open source? Or if not, are you thinking about sharing it?
Yeah, so yeah, this is an interesting question. So we actually sold we actually sold intellectual property for the operator in the past. I don't know. It's very recent, in the past couple of months, to a storage company. Um, so yeah, we're still collaborating on that. On the development of that operator. We're definitely providing feedback with new features that we had originally kind of like envisioned. But yeah, so I don't know. The open question of its open sourceness is
All right.
yeah, not in our domain, unfortunately,
I
anymore.
understand. But so it sounds like we are hitting the spot, right? Like if a company was willing to acquire the IP, it sounds like you did something amazing, and it's solving an industry issue. Like, considering that Kubernetes is an open source project, I hope that this company will think about making this kind of a standard. Like, what's your personal opinion? Like, do you think that vendors or the Kubernetes community, like the Kubernetes ecosystem, if I may say, should come together to develop standard for operators? And do you even think operators are kind of the end game, or is it a milestone towards something perhaps a bit more elaborated? Rick Vasquez, one of DOK member, wrote an article on the news stack. We'll share it in the chat, where he argues that operators are a good good first step, but that ultimately database will need to better integrate natively with Kubernetes. So how do you see operators standard playing? Like, is it something that you've seen emerging, or something that's not there at all yet?
Yeah, I mean it's hard to say whether something will completely replace it. I think the amount of logic that needs to be encoded in the way a database interacts with Kubernetes. Um, when we were developing the operator ourselves, like there were specific things that we kind of thought, oh man, I wish Kubernetes had better support for this kind of abstraction or something like that. So I think the emergence of additional abstractions may sort of ease the amount of things that operators have to implement themselves. Um, and the I guess the further reaching these standards progress, the less and less there will be for operators to implement themselves. Um, that would reduce the sort of sprawl in the quality of operators, or I shouldn't say quality, but just the variation across operators that you'd see as you examine this the sort of operator landscape. So yeah, I think development of additional abstractions in Kubernetes proper would go a long way to kind of limiting how much operators have to implement themselves, which may make them, more palatable to end users.
Right, like variation, I think is the right word. I think today it's a bit to do it as you want. Also, another great article on the news stack where the writer argues that operators should most of the time only be developed for stateful needs and not for stateless. So, the writer was arguing that a bunch of companies are writing operator for stateless use, which should not be the case, because Kubernetes, should solve that, and it's just using. It's kind of like, if you have a hammer to for a nail and then you use a hammer for a screw. It's the tool works, but it's not the best one. So I think there is also kind of a misunderstanding in the community about what are operator for, and so it sounds like there is really something we need to dig here. So let's take a step back and actually looking at some of the question of the audience. It sounds like you are, very accomplished company when it comes to hosting a stateful workload on Kubernetes. And one of the questions is like, let's take a kind of global approach. What type of Kubernetes technologies are you using to make this possible? Are you using stateful set? Is one of the questions. And also, what type of backend storage are you using? Is there any SAN involved in your infrastructure?
Yeah, so we use a couple of different storage drivers. The one we're commonly using now is Portworx. Um, and I don't know the audience members' level of familiarity with it, but it essentially allows us to use local storage that's present um, on the compute hosts that comprise like a Kubernetes cluster to create a storage pool that Kubernetes can then carve out volumes out of. And um, the Portworx has a product called Stork, or it's a part of their portfolio that you know takes the placement or takes the locality of storage into account when scheduling the actual workloads. So previously I said workload scheduling was handled by Kubescheduler. It's actually not. It's predominantly it's being offloaded to that Stork scheduler. Um, so yeah, that's been our strategy for storage predominantly.
So actually, Portworx is a platinum sponsor for the data on Kubernetes community too. So thanks to them, we can make this happen today. So we are grateful to have them on board. So it's quite interesting. Like basically, we are really seeing Kubernetes is kind of shifting the industry to create new paradigms to make this kind of container-focused architecture made possible. And so, it's something that has to be done by the open source community, but also by vendors. And we've definitely seen a lot of great things happening with Portworx. So let me look at the list of questions if there is any other thing.
We got one from YouTube if you want.
Could you send me in
What is
Slack?
the storage backend for the databases? Is there SAN involved?
Yeah, that's
You got it? So
the one I just asked.
you.
So Ara, I know all of this is a work in progress and not everything is perfect. If you had a magic wand, what would you ask it so that you could better run your data on Kubernetes? Let's be wild.
Yes.
Your wildest dream.
I don't know if you'll get a very wild answer, but one of the things that we wanted to model with custom resources has been the relationship between different database clusters. So think perhaps cross data center replication or something like that. But we wanted to represent these relationships also in a generalized way. But oftentimes, those kinds of relationships are going to span multiple Kubernetes clusters, right? If you have a database that's deployed in data center X and another one deployed in data center Y, that is generally going to involve separate Kubernetes clusters. So one of the things that I've been looking at for some time and have been hopeful that would progress based on community-driven efforts has been sort of the standardization of multi-cluster or federated environments. I think the last Kubecon I was at, I attended the talks on KubeFed, but I've had I've had deep interest in seeing how that develops. There have been a lot of companies I've seen in the last couple of years that have put out products or are developing products to support some various facets of multi-cluster environments. But if we were to have an overarching community-driven standard for how to approach these kind of topologies, it would make planning and modeling these sort of cross-cluster abstractions that span Kubernetes clusters much less challenging.
That's actually not the first time I hear this cross-cluster data center issue. Can you share briefly, not too much in depth, what's the actual issue? Is it a networking issue? Is it design issue in terms of system of Kubernetes? What are the challenges that makes this difficult at the moment?
Yeah, so if you wanted to define, let's use a hard example. Let's say we wanted to set up Kafka clusters and enable some sort of geo-replication using something like Mirror Maker, right? And we wanted to define that declaratively using some API. We would need some kind of federated view of our environment, right? We would need to know the current state of cluster X and Y in a common place to be able to define that higher order relationship across those clusters. So that federated view is, I think, something that things like KubeFed could provide. the sort of thing that I've been seeing, I think the problem is multi-cluster probably means different things to different people, right? So you have different products that, may address it from a networking perspective, right? They allow, routing between pods in one cluster to another or something to that effect. But if you want something that federates state, gives you a federated view of everything that you have running everywhere across all of your Kubernetes infrastructure, that sort of thing, I think we're still, something like that is also really, you don't want to make an investment on something like that and then realize a year later that they're moving away from that approach, like what happened with kubefed, v1. It's such the role of something like that would be so integral to how you're doing everything that it's something that you would want to have some sort of staying power, right? Some sort of clear, community-driven direction, that'll make you feel okay relying on it. Yeah.
So it's not something you are going to build and then sell to another company. I think Dreamworks might become a software company after all, right? That's your new business model. So it's very interesting that you speak about declarative way to state what you want, and we spoke about the benefit of having a standard way to deploy all your applications. So, and it's something we discussed a little bit before. But what do you see new pattern emerging in terms of technology, thanks to this new data management concepts that are coming out of the OK? And as you say, I can also share my input on that, but I want to hear from you first.
Yeah, for sure. So I think for me, the way I kind of see this paradigm shift for us anyway has been largely, the way Kubernetes has influenced the way we think about different workflows. It's reduced the cost associated with spinning up new environments so much to the extent that we have new possibilities that are available with us with regards to how we devise new sort of operational workflows. But yeah, as you said, I'm curious to get your thoughts as well.
Yeah, so I was sharing with Ara, like when car came, mechanical cars, people were scared about them, and so then the constructor would put a fake head of a horse on top of it, so that people would think it's like a horse, it's just a horse with a different shape, and so people would get used to it, which obviously is completely wrong, right? Why would you do that? And so I think in some ways it's what's happening today with data on Kubernetes is that we are moving existing paradigms, products, technology to Kubernetes. But really, I believe that we are going to see new ways, new product, new technical implementations that were previously not possible because we didn't have this orchestrated container power. And so one idea that may or may not be relevant is we speak a lot about data privacy and compliance, but user data, could containers be a way to safeguard the user privacy by using containers that we could move potentially across different services or product. Facebook has been in the news, a lot of issue around privacy. So I'm just curious actually if some people in the audience are listening to our talk, have ideas, please share them on Twitter, on our Slack. We'd love to hear from you. So I'm going to take more question from the audience. We have 5 minutes left, Ara. A question from Patrick McFadden asking, what would you feel is important for vendor interoperability in Kubernetes?
Vendor interoperability. I think
what's
I
important
think it kind of
for vendor? Like what are the important elements of this?
Well, I think it kind of relates to what we were talking about before. If I'm understanding the question correctly, like I think it's difficult because there just aren't there aren't any standards to govern interoperability. So yeah, like it's it's something that I hope kind of progresses with the emergence of new sort of like core abstractions to kind of support support that kind of interoperability across operators.
All right. So I've got the message from Bart that we need to wrap up. Ara, do you want to share anything? Maybe you're hiring or this type of thing, like anything that you want to share with the audience. Now is the time.
No, I don't have anything to share. Thank you for hosting, Sylvain. I had a pleasure talking with you. Oh yeah, thank you very much. I hope we see a lot of new topics emerge in this area over the next few years.
Thank you, Ara. This was extremely interesting. I'm passing the mic to Bart. Thank you, Ara. Bye bye.
Be careful what you wish for, Sylvain.
Bye bye.
He's passed the mic.